Let's now talk about the states of matter. Now, matter is the stuff from which we are all made. And scientists have found that at a very basic level, it can exist in three different states: solid, liquid, and gas. So let's have a look at the three states of matter and try to understand a little bit more about them. I have here a piece of ice. Now this is water in its solid state. Now if we could zoom in 2 billion times, so that that block of ice was about the same size as the county, then what we would see is something similar to this. Not exactly like this. This is a model of what a solid might look like. First of all, it is different because this is a model of something like salt, and the crystals that water ice form are hexagonal, and hence why snowflakes are like they are. Also, there are no bits of metal inside an actual piece of ice, and these model the connections between the atoms. You see, what happens at a microscopic level on the atomic scale with a solid is that strong forces hold the particles close and in a regular pattern. But when it gets warm, it causes vibrations to occur through the whole lattice structure. Another state of matter is liquid. Now, we are familiar with the properties of liquid. It can flow, it can take the shape of the container. But what's going on an atomic scale with liquids? I have here a box which is full of packaging material, and you can see that it flows and fills the box in the most energy efficient way that it can. This is very similar to an atomic model of a liquid. The particles in a liquid form no particular structure, they just can flow, and weaker intermolecular forces hold them together. But there are still some forces that hold it into the bottom of this container. And so you can see how this, 2 billion times bigger, is what produces this. Now this water here is not the only water in this bottle. At the top there is water vapour, the gas state of H2O. Now sometimes you might have heard of the word steam, but steam is what comes out of a kettle. It's superheated water droplets suspended as an aerosol in the air. But this is those droplets have broken up and they are individual water molecules but bouncing around in the air. The best model I can think of for this is what I've got here. I've got just a few of the water molecules trapped inside of a fish tank wrapped in cling film. Now you can see that they have complete freedom to move wherever they like, occasionally bouncing off each other, bouncing off the walls of the container. This is my atomic model of a gas. Now with most of the elements in the periodic table, most compounds, most substances, the density of the solid is greater than the density of the liquid, which is denser than the density of the gas. There is one exception to the rule, that is water. With water, the ice crystals have to get further apart to arrange themselves in water ice than they actually are in liquid water. That means the density is abnormally lower for water, ice, than it is for solids of other substances relative to the liquid state. It means that water ice will float, but normally ice of any other substance, say like liquid bromine, will sink.